Okay, cool. So I'm recording now, and I got another answer from Reem here. I got 16% for 31 and 4.64% for 30. Okay, so let's have a look at this. So yesterday I mentioned for you guys to try example number 30, and the formula is pretty straightforward for this calculation. It's the percent concentration in terms of weight and volume. So you take the weight of the solute or active ingredient and then divide it by the volume of solution in meters. So, or not meters, milliliters. And it's really important here that you use grams and milliliters for this type of percent. So if we had liters or kilograms or even pounds or something, we would try to convert it first. Luckily for us, for number 30, it's already done. So I have 5.57 over 120 grams and milliliters. Now you'll notice that the units don't actually cancel. And that's just kind of one of the things about using this weight and volume percentages. We just kind of, because we're using grams and milliliters, we just write down the answer. We don't need to worry about units, but it is really important to make sure you have grams and then milliliters. So we get 4.64%, and that's it. Okay, what about 31? 4 grams of glycerin. We've been talking about glycerin a fair bit, I guess. 4 grams of it is dissolved in a liquid to make 25 milliliters of solution. So, right, we have our solute. We have our solution. So again, very easy. 4 over 25, and that's it. Well, times 100, of course. Okay, so 4 divided by 25, 16%. Just like Reem said in the chat. So yeah, they're pretty straightforward. Let me just check the chat. Okay, perfect. Okay, let's look at a harder one, something a little different. Now, again, you guys know we don't do every example in this book, the workbook. There's a million of them. So let's look at something else. Okay, this one has milligrams. Okay, 36 could be good. Okay, let's look at 36 and maybe 37. Actually, a lot of these are pretty good here. Okay. Let's start at 35, actually. Okay, so an injection contains 50 milligrams of pentobarbital sodium in each milliliter of solution. What is the percentage strength of the solution? Now, this one, a little bit more challenging I'm not putting a star by this because it's important, but this one's a little bit more work than the others. Notice here, I'm not given any information, like I'm not given the amount of solution. All I'm given is that it's a 50 milligram strength. So there's a bit of work that I need to do for this. First things first, I'm going to change milligrams to grams. So you guys should know how to do this by now because you did it on the test. We can change the milligrams to grams. So 50, 50 milligrams times 1 gram over 1,000 grams equals 0.050 grams. You don't actually need to put the 0 there, but you can if you want to. Okay. So, I mean, that's basically it. For our answer. So our percentage strength of weight over volume, it says that it's 50 milligrams in each milliliter. So it's 0.050 grams in each milliliter of solution. So it's only one. And then I times it by 100. So I would get a 5% solution. Each milliliter being just 1 ml. Oh, by the way, 50 milligrams per milliliter. This is typically a measurement sometimes you might have heard of in chemistry where we would use parts per million. But anyways, in this case, we're calculating a percent. So we have 50 milligrams in 1 milliliter. I change it to grams. That's it, 5%. Pretty straightforward. Okay. Example number 36, pretty much the same thing. It says a drug formula contains 54 milligrams of antipyrine and 14 milligrams of benzocaine in each milliliter of solution. So again, the same thing for this calculation. We would change the milligrams to grams. So 54 milligrams, change it to grams. Okay, and I could do that for each of them. I don't know why I'm doing this one because it is pretty much the same thing. Oops, mg, there we go. All right, so I would get 0.054 and I would get 0.014. It's in each milliliter of solution, so my percentage of my weight and volume is the same calculation, exactly the same as I did before. Okay, and same thing here. I guess I should have picked different colors to make it look a little more, I don't know, exciting, I guess, if you could call it that. You don't need to put your units in for this one. I'm just putting them in, but you certainly don't need to, because again, our answer in percent is always unitless, meaning you just include the percent sign. You don't need to say grams per milliliter or anything like this. So this is 5.4%. And this is 1.4%. Pretty straightforward. The reason I'm doing example 35 and 36, even though it's kind of very straightforward, is because you do see this type of calculation a fair bit. This is related to parts per million. So even though it's so easy, we're dividing by 1 in each case, you do kind of see this in like a recipe or something like that. All right, cool. I had the chat was going crazy, so I was a little nervous, but no, that was just people sharing their answers. Okay, let's see. Now there's mixed review down here, but before we get into the mixed review, let's do one more, and I'm going to. Ooh, these are two good practice. Okay, let's look at 38 and 39. And I'm going to ask you guys to practice 38 and 39, but now these are harder than the normal ones. So I'm going to give you a bit of information first. For 38, you guys are looking at making a pound of sodium chloride solution. Or you're using a pound of sodium chloride solution. So one thing is 1 pound is 454 grams. So you'll need that for the first one. Okay, so that's good. I don't think you need anything else. Nope. And for 39, you got a percentage, you got a specific gravity. Nope, so this one's good as well. So these are now, it's early in the morning, and these aren't the easiest ones, but this is a good challenge to see, if you can do 38 and 39, you can do pretty much any of these weight ones. So why don't you try 38, 39? Remember the formula. You want to take the grams of solute over the milliliters of solution. Oops, and times that by 100%. The other formula you might need for number 39 is the syrup. You might need one of your specific gravity calculations. So the weight of your liquid, I don't know if you're going to need this. I haven't done this one yet. I'm going to wait for you guys to do it, but you might need this. Equal volume of water times specific gravity. Sorry, I'm talking to myself. So you might need that formula for number 39. Okay, I'll stop talking. I'll give you guys 5 minutes or so for this question, and then I'll be back. All right, so good luck. You can put your answers in the chat if you wish. All right, just another minute or so, and we'll look at the answers here. Oh, there was a question earlier I missed. I'll go back to that in a minute. Um, and somebody's giving me, okay, so 38, I get an answer. Looks pretty good for 38. Yeah. Mecca, I think you're correct there. So I'll give you guys another minute or two to see if anybody can give me example 39, and then we'll look at the answers. And then there's a question from Lolo that I'll answer in a minute. All right, so let's look at the answers for these two. Oh, let me check the chat. Okay. Yeah, I got a couple answers for 39 as well. Um, Not sure if 39 is, you both got the same answer for 39, but I'm getting something a little different here. So let's have a look. See if I could be wrong. It's happened. One thing, there was a message in the chat there. It said earlier, why am I dividing by one? Because it says right here, each milliliter of solution. That's 1 milliliter. So that's why I divided by one. Okay, I hope that makes sense there. Now let's try these. I'm going to erase everything here so I have room to write. Okay, so let's look. Let's see. Oops. Oh, hold on now. All right. So number 38. How many milliliters of a 0.9 sodium chloride solution, normal saline, can be made from 1 pound of sodium chloride? All right. So first things first, let's figure out how many grams are in 1 pound, which I already did. 1 pound is 454 grams. So my percent is 0. Well, I guess I don't need to write that. I'll just say 0.9% equals 454 grams over X times 100. So that means, well, very simply, X is going to be 454 over 0.009, and we'll get our answer. I skipped a couple steps there with the math, with rearranging, but if you guys got any questions about that, let me know. And I end up getting a very large number, 50,444 decimal 4, and it's actually 4 repeated milliliters. Not too worried about in this course. If you guys remember chemistry, significant figures, I don't really care. So as long as you had around 50,400 milliliters, that's fine. Very, very big number. But again, we're using a pound of sodium chloride. Okay, for number 39, I'm getting different answers, but let's see. A type of syrup is a 65, that's very high by the way, solution of sugar or sucrose in water. The syrup has a specific gravity of 1.123. How many milliliters of water should be used to make, oh, this is a tough one, 1,250 milliliters of the syrup. Okay, so this is a very tough one. Okay. So I'm just thinking of how I'm going to set this up. The problem with this one is we have a 65% solution. It's going to be equal to the mass of my solute. Now, the weight of my solute, oh, sorry, I erased the formula. The weight of the solute is going to be equal to the equivalent weight of water from below times the specific gravity. So here, let me write this down. So the weight, let me write that down first. Let's start with the weight. So the weight of my liquid will be the weight of the equivalent weight of water. So the volume of equivalent water times the specific gravity. Okay, now this one, I think this one's, I'm hopefully going to set this one upright. Okay, so that means our 65% solution is going to be, well, we don't know the weight of the liquid or the equivalent weight of water, so we're going to call that X. And we can multiply that X by our specific gravity, 1.123. Now, what about the bottom? The bottom is also going to be challenging for this. It says how many milliliters of water should we add to make up 1,250 milliliters of syrup? Well, that means that this is going to be our total amount. Luckily for us, we don't have to worry about that. This is the amount of our solution. Okay, and then I times that by 100%. Okay, now the question is worded very difficultly because it's like some of you guys are thinking, why is he putting an X up there when it's asking for how many milliliters of water? We're going to calculate that after, but we can't figure that out until we figure out how much solute, or in this case, it would be sucrose or sugar that we're adding, right? If this is the total, you need to find out how much of the sugar or sucrose we're adding. So let's solve for X. So X is going to be 1250 times 0.65 over 1.123. And and this is not going to give us the answer, but this will give us the first part of the answer. Oops, hold on, I did something wrong on my calculator here. There we go. So I get 723.5 grams of sucrose. Oops, got an email there, hold on. The email pop-up went right over where my mouse, or my where I was trying to write. Okay, I'm still not done this question. I'm actually not even close to being done this question. Well, I'm about halfway, because now what I need to do is I need to figure out, how much milliliters of water should be added. And now I have grams of this sucrose. So next thing, I need to figure out the volume of my liquid. So the volume of my liquid is the volume of equal weight water over my specific gravity. Okay, so now what am I trying to do? I'm trying to find the volume of this. What is the volume of this? And the reason I'm trying to find the volume of this is because I'm trying to figure out how much water I'm needing to add to make this amount. So volume of equal weight water, well, that's easy. It's 723.5 milliliters over my specific gravity, which is 1.123. Okay, so divided by 1.123. Oops. Oh, why did my calculator do that? That's weird. Anyways, hold on. My calculator said something really weird. There we go. 644.25 milliliters. And now finally we can answer the question, how much water? Well, it's the 1250 milliliters minus 644.25 milliliters will give us the answer. Okay, so I get 605, or well, let's say 606 milliliters. Whew, a little bit of work, or I guess like a lot of work for that type of question. So let me kind of just go over what I did, and we'll kind of go over the answer here. So a type of syrup is 65% sucrose in water. Okay, so 65%, no problem. The syrup has a specific gravity of 1.123, and it said how many milliliters of water should be used to make 1,250 milliliters of syrup. Well, this guy on the bottom that I'm circling now, this number is the milliliters of water plus the milliliters of the sucrose solution that we're adding together. So the first thing I did was figured out how many grams of sucrose I put into the solution. Okay, so X was my mass of sucrose. And the reason I multiplied it by 1.123 was because that's the formula for the weight of this liquid. So I took the volume, the X here would be the volume of equivalent water, multiplied by 1.123, and there I get my answer. Let me just try something. 723.5. I just want to make sure I did my calculation correct. Yeah, okay. So now in this part down here in the blue, now that I knew how many grams of sucrose I needed, or how many grams of sucrose were mixed together, I converted that back to a volume and then subtracted from my overall number. So overall, I had 1,250 milliliters of water plus sugar. So if I subtracted the amount of sugar or sucrose, I would be left with how much water I had. And that's it. Not too bad.
Sir,
Yes?
we normally use water as a solvent. Why did you use sucrose as the solvent?
I did not use sucrose as the solvent. Um, where do you see that?
In the first equation, 65% is equal to x into 1.123.
Yeah, but so this X on the top, remember your formulas, this is the solute. The solution is on the bottom.
It says how many millimeters of water should be added to make 1250 milliliters of syrup.
Yes. So, okay, so the X on the top is the solute. The 1250 is the solution. And again, I didn't use sucrose for the solvent because X is my amount of sugar, like my solute.
But sir, it says 1250 of syrup. Syrup is sucrose.
No. The syrup is the whole thing. A type of syrup is a 65% solution of sucrose in water. The syrup is the solution.
Okay, thank you, sir.
No problem. Okay. All right, guys. So why don't you try? Oh, sorry, I got a message in the chat there. Somebody in the chat says it's a private message. Can I do 37? I certainly can. So 0.5% weight over volume. Calculate the number of milligrams in a 25 milliliter injection. So X, I'm just doing this because somebody asked me to show this to them. So X would be 0.005 times 25. Then we would get my answer. Oops. So I get 0.125 grams, and it says calculate the number of milligrams. So I multiply it by 1,000. And I would get 125 milligrams. All right, cool. Oops. So we're almost done actually for today. Now we can put it all together, and there's a million mixed problems here. And obviously I'm not going to do all of these. This is for you guys to practice. So what I recommend is for you guys, maybe, over next few days or over the weekend, is try some of these mixed practice ones. Now, all that means is these could be questions that are any of the three types. They could be weight and volume, they could be volume and volume, or they could be weight and weight. So I'm going to leave this for you guys to practice. And if you ever have any questions on this, you can let me know. Again, the answers are written there in red right next to it. So this is definitely something I would practice. Okay, all right. Let's just do one more thing. Maybe we'll just do the bottom of page 30, or sorry, we'll do page 35 here, and that'll probably be enough for today. So, section 3.3, concentrations and dilutions. We just, in section 3.2, looked at different ways to write concentrations. So different than in chemistry, instead of using moles per liter or parts per million, we used percentage concentrations. Now we're going to look at, very quickly, but we'll kind of start this today and finish it tomorrow. We'll look at two ways to solve concentration and dilution problems. So first things first, if you can't remember what a dilution is, it means to add water or add solvent. And I'm going to say solvent, but in brackets, I'll write the word water. It's typically when you dilute something, you're just adding water to it. But in medicine, we've learned that a lot of solvents can be things like alcohols and glycerin. So it's kind of, you add more liquid to water down to kind of reduce the concentration of the solution. So that's another thing I should write down. Dilution, it reduces concentration. So, an example is if you guys were drinking tea or coffee and it was too strong, what in chemistry or in this course we would say too concentrated, you just add water to reduce it or to dilute it so it doesn't taste as strong. So, there's a question in the labs, and I know all of you guys were in chemistry because I had half of you. There's always a question in the lab that we ask. It's why would a company or an industry even bother? What's the purpose of buying a concentrated chemical and then diluting it later? And the real answer is, if you work at a pharmacy or a hospital or a chemistry lab, and, for example, you're working here in Qatar and you need to ship in medicines or chemicals, if you buy it concentrated, you can ship in a little small bottle, so it's cheaper. There's less waste, there's less packaging, it takes up less space in the shelves, and then you can dilute it yourself and you can control it. And in medicine, again, you guys know I'm a math chemistry teacher. I'm not a pharmacist, but in a pharmaceutical situation, you're making different concentrations for different patients depending on what their prescription is. So again, if you wouldn't be asked in this course because it's a math course, but why would a pharmacist get a concentrated form of a substance and then dilute it? It saves time, it saves money, there's less space taken up at the pharmacy. You can control the concentration, or what we would say, control the active ingredient. It's very, very useful. So, an equation you've used before, and honestly, you've used more of this in chemistry than anything, is the amount of ingredient is the concentration times the quantity used in preparation. So, where have you, what you've seen? Hold on now, let me write something down here. In chemistry, you've seen this as moles equals C times V, right? If you guys remember that. But now there's no moles in this course. We're not dealing with N or anything like that. Don't worry. This formula, which is in, this is not in your data sheet or not in your formula sheet. But I can always add it to it. I mean, it's not a very hard formula. The amount of something is the concentration multiplied by the quantity used in preparation. So again, in chemistry, we would say moles is equal to C times V. So let's look at a couple of examples, and then that'll be it for today. I won't go too long. It's 8 in the morning. We'll look at some more of these examples tomorrow. But let me just show you these two examples. Okay, so example number 1. Calculate the amount of milliliters of ethanol available in 300 milliliters of a 20% V over V solution. So this is a volumetric solution. So again, amount is the concentration times the quantity. This quantity of preparation would be like the amount of solution. Okay, so C times Q, it's a 20%, so we change that to 0.2. Remember, you always change to decimals when you do this. And then you multiply it by the quantity, the amount of solution. So we have 300 mils of solution, it's 20%. That means 60% of it will be ethanol. Okay, let's look at a couple more. How many grams? I think this is a typo here. Sorry. How many grams of active ingredient are there in 320 grams of? This is a typo, I think. Maybe not. Like I'm not sure if they mean 1.5% or if they mean a 1 to 50 solution. Let me just check something here. Okay, hold on. I think I can figure this out, or figure out the answer. The answer is 6.4. So again, what I'm trying to do, guys, is to see if they mean, if whoever created this book means that it's 1.5% or a 1 to 50% solution, as in like a ratio. They're very different numbers. So let me see. If it's a typo, I can fix it. Okay. Oops. Times 320. Yeah, it is. Okay. That's what I figured. Okay. Guys, I wouldn't ask you a question like A. I would ask you one like B. So this is a 1 to 50 solution. What this means is it means 1 part solute to 50 parts solution. So the percent concentration here is 1 over 50 times 100, of course. So it's going to be 2%. So now I can actually figure this out. So in red here, I'll switch my color to red. I would ask you more something like B, by the way. But anyways, if I wanted to find the amount, it's my concentration times Q. So it's 2% or 0.02 times 320 grams. That leaves me with my answer in grams, 6.4 grams. Okay, that one a little bit challenging. I would do it more like B. So let me check the chat and then I'll look at B. Okay, how many milliliters of active ingredient are there in a 225 milliliter 30% solution? So again, very straightforward. I like this one. The amount is C times Q. The concentration times the quantity. And that's it. That's a good one. All right, so 0.3 times 225 gives me 67.5. Now, some of you guys might be wondering, how do you know what unit it is? Well, it's the unit you're using in your quantity, in your Q. So this would be milliliters. All right. So guys, that's it for me today. We could go a little bit more, but it's pretty early. So I think we'll leave it at that. Are there any questions? If there's no questions, I'll see you tomorrow, and we'll start doing some solving. Gets a little bit more complicated tomorrow. Okay, guys. Thank you, everybody. Thank you, Asma. Thank you, Kalsum. Thanks, everybody. No problem. Thanks, Asma. And Serena, thank you. Have a good day, guys. Take care.